All right, in this video, we're going to do systems of equations, which means we're going to look to see if two lines, or near the end of the video, three lines share a point in common. Right, and so we remember our equation of a line is ax plus by equals c. Right, and it says I have two equations, so I write it again as ax plus by equals c, and then I add my little subscripts. I put ones in the first equation on a, b, and c to represent the first equation. And I put twos on a, b, and c in the second equation to represent the second equation. Remember, x and y are variables, so they are infinite solutions when you're on a line because there's infinite x's and infinite y's. Now, we're going to learn three ways to solve these things: by graphing, substitution, and elimination. Now, if two lines cross, they are consistent, and that means they share a point. If two lines are parallel, they never cross, and they are inconsistent, so they have no points in common. And then if I have two lines, which I'll redraw so you can see here. So I have a line, and I have another line right on top of it. There is infinite solutions because they're the same line, and therefore they are dependent. So in this video, we're going to go through and solve some of these. Using these three methods, you can see how to solve them and see the types of systems we have. So, say we have the equation 3x plus 4y equals 12. And then we have 3y minus 4x equals 9. All right, so there's our two equations. Actually, yeah, that's fine. So my first equation will solve for y. So this method, we'll do is the graphing. In two ways, in multiple ways you can do it. Graphing calculator, obviously, but I'm going to do it by hand. So if I'm doing it by hand, I can do the table method that we learned, where we pick points, or I can put it in slope-intercept. And I can do that by solving for y. So that's the method I'm going to do, is the slope-intercept. So to solve for y, I subtract 3x from both sides. I get 4y equals negative 3x plus 12, divided by 4. Y equals negative 3/4 x plus 3. So I know my intercept is the point 0, 3, and this is my slope of negative 3/4. Then I solve the second equation. So 3y minus 4x equals 9. Oops. 4x, not 4y. And now I am going to add 4x to both sides. 3y equals 4x plus 9. And I'm going to divide by 3. And y equals 4/3 x plus 3. So you can see, again, our intercept is 0, 3. And my slope is 4/3. Now, I don't even actually have to graph this to see the answer. They have the same intercept, so that is the answer. But I'm going to do it just so we can see it. And this is really the only time I use graphing method. I never really used the graphing method unless I think the lines have something in common that I can see very quickly, where I don't actually have to graph. In the homework, there'll be a couple problems where it will help you graph just so you can see this method, but I rarely use it unless I see this a common thing. You may, sorry, you may or may not see this until you get much better with lines, right? But let's just graph these so we can see it. So my first line, I start at 3. And it's -3, 4. So I go down 3, 1, 2, 3. And I go to the right 4, 1, 2, 3, 4. And there's my first line. Now my second line, again, we start at 3. Now I could go up 4 and to the right 3, or I can make it double negative and then go down 4, 1, 2, 3, 4, and to the left 3, 1, 2, 3. Remember, 2 negative and a positive, so I can go either direction, just be consistent. And there is my second line. And I share the point 0, 3. So this, I'm going to make a curly bracket. It's not, it's a point 0, 3. So this is consistent. And this is a special case, right? These two lines are perpendicular. They are perpendicular. And I know that because the slopes are the negative reciprocal of each other. In other words, I took -3/4, I flipped it, and I made a positive. So they're perpendicular. Not all consistent lines are perpendicular. They don't have to cross at a 90-degree angle, which remember, that's what perpendicular means. They form a 90-degree angle. But in this case, this one does. All right, so there's the graphing method. And I wouldn't recommend this method unless you have graphing paper, because you got to see exactly where the lines cross. Or if you have a graphing calculator, or if you look at the two lines and it looks like there's something that I know, either they're parallel or perpendicular, so I can see that pretty quickly. Or if they share the same slope. I mean, sorry, that's what I'm saying, same y-intercept. All right, so the other method I like to use, because when you can't see how lines work so well, is the substitution method. So say we have 4x minus 2y equals -14, and x plus 3y equals 7. So the substitution method. And I have all the steps listed out on my OneNote that you have access to. Right? So, substitution method. First thing you do is solve for a letter. Well, we'll be consistent. Solve for a variable. Solve for a variable. And you can solve for a variable in any equation, right? And you can pick any variable. So I kind of like to look at the equations and look. And so I can look at the second equation. I can see x is almost already by itself. It has no coefficient attached to it. So if I subtract 3y from both sides, I get x equals 7 minus 3y. All right, so there's step 1 done. Now step 2, substitute it into the other equation. So we take this, the 7 minus 3y, and we substitute it in place of x in the other equation. So I get 4, parentheses, keep my colors consistent, 7 minus 3y minus 2y. Let me erase my line here. Equals 14. I'll call my team my substitute. So now we have one equation. So now solve for the other variable, right? So first thing I will do is use the distributive property and distribute the 4 through. I get rid of the parentheses. So I get 28 minus 12y minus 2y equals negative 14. Combine like terms, 28 minus 14y equals negative 14. Subtract 28 on both sides. Negative 14y equals negative 14 is negative 42. Divide by a negative 14. And y equals 3. Then last thing, solve by substitution. Substitute your answer into one of the equations. Now, you can substitute back into the equation you already solved for x. I always encourage you to substitute back into the original. That way, if you've made a mistake somewhere, you can check if you go right back to the beginning. So I'm gonna go right back to the beginning. And you want to substitute it into the other equation. Don't substitute back into the equation you just used, because it will work. It will always work because that letter is in it. But I want to make sure it works in both. So I'm going to substitute it into the other equation. So not letter, sorry, number. X plus 3, parentheses, and replace the y with the 3, equals 7. X plus 9 equals 7. Subtract 9 from both sides. Y, not y. X equals negative 2. So these lines cross at negative 2, 3. And the final step, which you should always do, is check. This answer should work in both equations. You can do that on your own at the same time on this video, and I'll make it longer than it's going to be. But you can put negative 2, 3 into both equations. You put in the first equation, it equals negative 14. Put in the second equation, it equals 7. And therefore, you know you have the right answer. So that's why I like these equation problems. You will know if you have the right answer because it will always work. So this, again, was the substitution method. Now, I'm going to do the elimination method, which I like to call the add subtract method. And I'm going to use the same equation, just so you can see that you get the same answer. So 4x minus 2y equals negative 14. X plus 3y equals 7. So this is the elimination method. Elimination method. So step 1, you can either add or subtract the two equations so that to eliminate a variable. Eliminate a variable. Note, you may have to find a number to multiply by to get this to work. So you may have to, I'm trying to think of the proper term. I would have said multiply. Multiply by a factor. And in this case, I do have to do that. All right, because if I can't just add these, right? If I add them, I get 5x plus y equals negative 7, and I didn't solve for anything, right? Because you have to eliminate a variable. But if I multiply this and second equation by -4, the entire equation, right? I will get -4x minus 12y equals a -28. Then I bring the first equation down, 4x minus 2y equals a -14. And I now add these two equations. -4x plus 4x is 0. This is what you always want to happen. My x is gone. -12y plus a -2y is -14y. And -28 minus -14 is a -42. And you can see now we're right back to where we were just a minute ago. I divide by -14. And y equals 3. And in step 2, substitute. So you substitute that back in. This time I'm going to substitute it into the other equation so that you can see what actually it does work. So if I take, I'm running out of room so I wrote so big, 4x minus 2 times my 3 equals -14. Yeah. -14. I get 4x minus 6 equals -14. Add 6, add 6. I get 4x equals -8. Divide by 4. Divide by 4. I'm going to apologize about that. X equals -2. And you see I get the exact same point again. -2, 3. All right, so those are kind of the two methods. Most of my students seem to like the substitution method. I prefer the elimination method, but it really just comes down to what you like to do. All right, so let's do 2 more ones here so we can see some things that may happen to you. So what if we have the equation 2x plus 2y equals 4? Then I have 1/2 x plus 1/2 y equals 1. Right, and I'm going to use the elimination. And when you solve these, you may use any method you like. And on the homework, it's going to tell you to solve them a specific way. Do a couple every way so you know how to do each method. But really, just solve. I want you to be able to solve these. So solve whatever method you like, because the computer's not going to know what method you used. So if I do the elimination method, I want to get rid of these fractions, right? But I also don't want to get rid of the fractions. I want to make that a 2. So again, if I multiply this thing by a -4, and I always multiply by negatives, that way I don't have to actually subtract, because a lot of times when people subtract, they do real well and subtract the first terms, and then they start adding everything else. So if I just multiply by a negative, I can just add the entire problem. So -4 times 1/2 is -2x. -4 times 1/2 y is -2y. -4 times 1, that is a positive 1. My marker just made a little note there. I don't know, this is some, why is that reset? There we go. Yep. Equals a -4. Bring the first equation down. 2x plus 2y equals 4. I add these equations. I get 0 plus 0 equals 0. All my variables disappeared. That means that this does not have a solution, right? Or has infinite, sorry. But my variables disappear, and because 0 does equal 0, this is dependent. There's infinite solutions. I can put anything in for x and y. And I could have seen this by kind of using the graphing method. If I would have gone back here and multiplied this by a +4 instead, I would have gotten 2x plus 2y equals 4. And these two things are the same. So they are the same line. So they are also dependent. So I didn't even have to go through this whole thing. Or I could have put them in graphing method and graphed them and realized they're the same line. Lots of different ways to solve these. But I wanted to show you the case. What means to be dependent is when you get down here in the two things, there might be zero, they may not be, but they will actually equal each other and the variables will be gone. All right, and then what if I have x equals 2y plus 6, and then I have 6y equals 3x minus 6, right? Well, I'm going to use a substitution method here because half the work's already done for me. I've already got a letter solved. So now you just take all of this and substitute it in for where x is. So I get 6y equals 3 times 2y plus 6 minus 6. So 6y, I distribute, equals 6y plus 3 times 6 is 18, minus 6. Combine like terms, 6y equals 6y. So 18 minus 6 is 12. Subtract 6y from both sides. Uh-oh, my y's cancel again. So I get 0 equals 12. 0 does not equal 12. So these are inconsistent, which means no solution. So there is the three methods, the three methods for solving a system of equations with two unknowns. Now, depending where you are in algebra, you might actually do a system of equations with three unknowns. So I have, again, my standard form, ax plus by plus, I'm going to add another variable, so it's going to be cz. And since I move c onto z, I got to make it equal d. Well, if I have three variables, or x, y, and z, I need three equations. So ax plus by plus cz equals d. Ax plus by plus cz equals d. And again, I'm going to put subscripts on my a, b, c, and d's to separate the equation. So I'll put 1s for everything in the first equation. I will put 2s for everything in the second equation. And I will put 3s for everything in the third equation. Now, you can do all the three methods that we've just learned for this. Now, to graph this will be challenging unless you have a computer that graphs in three-dimensional, because that's what this thing is. This is a three-dimensional. This is three lines crossing. And again, if they cross at the same point, they are consistent. If the three lines are parallel, they are inconsistent. And if they are, and basically if they're parallel, they're on a plane. So getting into a little bit of geometry. Or if they're all the same line, again, independent. Right. Now, the steps are the same. It's just I got to do them more often because there's three equations, right? So we'll try to attempt to do one of these on this video without making too many arithmetic mistakes. So say we have 2x plus y plus z equals 4. X minus 2y minus z equals 3. And 3x plus 3y minus 2z equals 1. So I am going to do a combination of them basically, because you can do that. And I am going to use, basically I'm going to do the first two equations. And I'm going to do the elimination method, because if I take 2x plus y plus z equals 4, and x minus 2y minus z equals 3, and I add them together, I get 3x, y plus a negative 2y is a negative, sorry, my eraser kicks on, negative y. The z's cancel, and I get a 7. And now I am going to take the next two equations and kind of do the same thing, but I am going to have to manipulate it. So what I'm going to do is I am going to multiply this first equation. I mean, sorry, not the first equation, the second equation. Actually, yeah, I'll do it. That's fine. I'll multiply the second equation by 2. Negative 2, which gives me a, I'll keep it blue, a negative 2x plus 4, no, that's 4, plus 4y plus 2z equals a negative 6. Bring my third equation down, 3x plus 3y minus 2z equals 1. And I'm going to add these together. Negative 2x and 3x is x. 4y plus 3y is a 7y. The z's cancel, which is what I wanted to happen. And negative 6 plus 1 is a negative 5. All right, so save room. I'm going to move these to the other side. So I'm going to move page, sorry. So 3x minus y equals 7. 3x minus y equals 7. And x plus 7y equals negative 5. X plus 7y equals a negative 5. So I'm going to use the substitution method. I'm going to subtract 7y from both sides. Right, so I get x equals a negative 7y minus 5. Okay, and now I substitute that into the other equation. So I have 3 parentheses negative 7y minus 5 minus y equals 7. So 3 times negative 7 is a negative 21y. 3 times negative 5 is negative 15. Minus y equals 7. Negative 21 y minus y, again, I'm running out of room, so I write so big, is a negative 22y minus 15 equals 7. Add 15 to both sides. Negative 22y equals 22. Divide by negative 22. Y equals negative 1. Now, if I take negative 1 and I put it back into, we'll say that equation. I know I say go back to the beginning, but you can't really do that one on this one. So I get x equals negative 7 times a negative 1 minus 5. Negative 7 times negative 1 is positive 7. So x equals 7 minus 5, and x equals 2. So I have 2 answers so far. I have a negative 1, and I have a 2. So I'll go back to my previous problem so we can see it again. I have x equals 2, y equals negative 1, and now I can pick any equation. I am going to pick the first equation to substitute these in. So I have, get that out of my way. So we have a 2 times the 2 plus a negative 1 for the y. Remember, I'm using, I'll circle it, using the first equation to solve for z. Plus z equals 4. So 2 times 2 is 4 minus 1 plus z equals 4. 4 minus 1 is 3 plus C equals 4. Subtract 3, C equals 1. So the final answer to this whole problem is 2, -1, 1. So hopefully these examples help show you all the different ways to solve these problems. And again, this video is solving systems of equations by either graphing, substitution, or the elimination method. And we can, if they cross, they're consistent. If they do not cross, they are parallel and inconsistent, or they're the same line, they're dependent, and there's infinite solutions. Thank you.